Hi everyone. So in this video we are going to demonstrate that how to configure IPv6 addresses on the router, and how to configure IPv6 addresses on computers. So for this lab, it means we will be doing a very simple lab which will be based on this IPv6 addresses. So we need one router. So I have taken router here, and then maybe we need PCs. So for that, first these are the switches. So you can see this is switch, and then we also need computers. So this is one, and this is second, maybe connected with this, and this is I'm making two networks. So I'm making two networks. I can give, let's suppose that we can use different colors for that. So maybe this color for one. So we can say this will be our first network, and in the same way if we select a different color, then we can say that will be our the second network. In this way actually we are having two networks. Just we have to configure these two computers, and this switch and this interface will be on one network, so we have to connect them. So for connections we have selected this cable that is straight through. So from Ethernet port to the Ethernet port of the switch, first connection, and here at the moment I have just pressed control key. So by using control key, otherwise you can just to select, you can connect them one after another. You will not have to do again and again. So if otherwise, just go to cable and click fast Ethernet and select any Ethernet port on the switch, and go to cable and select PC and select any fast Ethernet port on this switch, and in the same way select a cable and just select any. So fast Ethernet port from this PC to the switch, and fast Ethernet port. So and now this switch has to be connected with the router. So we just say gigabit Ethernet 0/1, and on this interface maybe gigabit Ethernet 0/0/0, and in the same way we are connecting gigabit Ethernet interface of the switch with the gigabit Ethernet interface of the router. So now we have these two networks which as per because we will configure these two networks in such a way that both of the networks will be in different networks. So they will be in different subnets. It means we need routing, and to connect them for IPv6 actually I have selected this unique local address. So we have global unicast address, and we also have unique local addresses. So unique local addresses are the addresses as like private addresses. So a private organization can use unique local address. So we can use global for just in the lab. So I'm just using this unique local unicast addresses. And how to create these unique local unicast addresses, we have a separate video on that how to create that, because these are the IPv6 addresses which you can create by yourself. You don't need to go somewhere for permission or anything. Okay, so here you can see these are just the 12 quartet. 12 quartet means the 1 2 3 4 5 6 7 8, sorry, 8 quartet, and in each quartet we have 4 hexadecimal digit, and 1 hexadecimal digit represents 4 bits. So 16 16 16 16, so what is that? 64, and then 16 16 16 16, that is 128. So okay, so on the same side, so exactly in the same way we have 128 bits on in this IPv6 address as well. Now you can see this is not the abbreviated form. We can write the same IPv6 addresses in abbreviated form. So you can see actually the rule to create is that just the initial two hexadecimal digits should be FD, and then we have this 40 bits which we have to select randomly. So we have selected these bits randomly, so you can select any one. And then we have the subnet, and then we have the user interface part, that is also 64 bits. It's exactly in the same way, and the difference is that here in the third quartet I have used A, and here in the third quartet I have used B. So this actually is in a different network because we have used different combinations here, the different combination of bits. So this actually identifies the difference in two IPv6 addresses. And then for this we have this subnet A, and also this is subnet A. So the subnet can be same, but actually already we have different IPv6 addresses. Anyway, now we can actually write the same IPv6 address in abbreviated form. So that will be FD00 and then 0/A/A, not slash, but this is actually colon, I'm sorry for that. So colon, and for these 4 zeros we can give 0 one time, so that's 0, and then colon, and for these leading zeros must be removed, so this is a if we want to abbreviate that, then we can remove them. And then also we have A, so this is the subnet part, and then we have the host portion, that is 1, so colon 1. So this is the IPv6 address. For example, we will assign this IPv6 address to this interface of the router, and on this side as well we can just do the same thing. So what we have difference is that this is same and this is same, and this is actually B. So here at this, in the third quartet, we have to make this B, and rest of the things are same. So this interface, this IPv6 address will be assigned to this interface of the router, that is G00/1, and on here we'll assign this IPv6 address to this interface of router, that is G0/0/0. So this is the difference you can see here. This is :0:B, and this is :0 and :A. Okay, now let's start the thing. So we go to this PC, for example, and here we go to desktop and give IPv6 address. So this is the portion for IPv4 and this is the portion for IPv6. So IPv6, we are going to give the IPv6 in this subnet, so that is FD00 colon, and you can see then we have 0 and then colon, and then A colon, and then this is the user interface ID for this router interface, so we are making this 2. So this is our IPv6 address for this computer, and then we have to assign here the prefix length, so that is 64, and we also need to give the default gateway information, so Control-C, and we are going to paste it. And this interface, so this interface of the router is going to act as a default gateway for us. So this is the IPv6 address which I have assigned here in default gateway. So we are done with this computer, and let's suppose on this computer again we need to assign IPv6 address. So there are other methods as well. So let's suppose that first, after this, we are going to configure this router, then we will configure that computer. Say command line interface, and then no initial configuration, and then we need to go to privilege mode, and then global configuration mode. In global configuration mode, and when we are using, or when we are assigning IPv6 address, or when we are creating IPv6 based network, we are recommended to use IPv6 unicast routing command in the global configuration mode, because this command will enable IPv6 on the interfaces of the router. So what we do, we say IPv6 unicast routing. So very strong command. This is going to enable IPv6 on the interfaces of the router, and it's going to allow the interfaces to forward the packets as well. And then after this, we go to that particular interface. So in this case, G0/0/0. So sorry, we write here interface and G0. So this G means gigabit Ethernet 0/0/0 and 0. So we are in this interface, and now we need to assign IPv6 address. So we need to say IPv6 and then address, and address is FD00/0 and /A/A and then colon and then 1. So this is the IPv6 address which we are assigning to this interface, and then we need to mention the prefix length. So this is prefix length, and done. So we assign the IPv6 address to that interface, and now no shut command, and that's done to make that interface active or functional. So we assign the IPv6 address to this interface of the router, and then we need to go to the next interface, that is G0/0/1. So we say interface G0/0/1 and enter, and here we say IPv6 address, and we say FD00:B:A and then ::1. So this is the address which is shown here. So we have selected this unique local unicast address which has been assigned to this interface of the router, and now we need to give the prefix length, that is 64, and we are done. And then no shut command. Then so we have assigned the IPv6 address to both of the interfaces of the router, and Control Z. Now if you want to see here, then we can say that we can see the IPv6 addresses which have been assigned to the interfaces. For that we have a command, that is show IPv6 interface and then brief. So this command will give us the information about those interfaces. So you can see show IPv6 interface brief, and this is the first interface that has been assigned the IPv address. You can see here this is the IPv6 address for that, and this address is the link local address. If you remember from the video, so this is the link local address. So this must start with FEAT, and this rest of this network interface part has been calculated using the MAC address. So that has been calculated automatically by the router interface. So in the same way, this is the IPv6 address which we have assigned, and this is the link local address of that particular interface. Clear? So now we have we saw that interfaces have been assigned IPv6 address, and you can see the information in show IPv6 route as well. So you can see here it shows that we have the connected route, and we have local and connected and local. So we have these connected means this subnet which is connected, and local means specific address or specific host. And so this is the address which we have assigned as a network. So we are done with that. Now let's suppose that we are giving IPv6 address to this PC. So for this PC we need to give IPv6 address in this subnet. So that is FD00 and then :0:B, then :A, and then : because this is the network interface part, that is 1 and 1, and then we give the prefix length part, and we also give the default gateway information. So this is the default gateway, but for this PC we are using, for example, we are using 2. So this is the 1. So : :1 has been assigned to this interface of the router, and : :2 in the network, in the interface ID part is being assigned to this computer. So we are done with that. And now let's suppose we just copy this IPv6 address, and we want to check the connectivity from this PC. So we want to check the connectivity from this PC to say to this PC. Okay. So what we do here, we say ping, and then we say paste. So this is the IPv6 address of this PC. So press enter, and you see we are getting reply, and this says that lost is 0% and we sent 4 packets and we received 4 packets. It means perfect. So with this basic configuration we are able to ping from this computer to this computer. Both of the computers actually are in different networks, but we have used the unique local unicast addresses. And then for example on this PC, let's suppose we want to configure this PC. This is the PC, and here we go to desktop and IPv configuration. Now instead of giving this IPv6 address by ourselves, what we are going to do, we are going to use another feature of this IPv6, that it can automatically assign IPv6 address to this PC using a method that is known as SLAAC. So stateless address auto configuration. So what is being done here, we just click automatic, and with this automatic you can see in IPv6 address part, you can see the one IPv6 address has been assigned automatically by a method that is known as SLAAC. So here the way is that it has selected, it has received the prefix part from this router. So this, you can see the half, so 64 bits. So 64 bits information, this will be 16 hexadecimal digits have been received from this interface, and this remaining 16 bits has been calculated by using the MAC address of this computer, that is known as the method is known as EUI64 method, that is extended user interface. So by using that method, this computer has actually calculated its interface ID part by itself, and remaining 16 hexadecimal digits have been used from this. You can see here. So it means this is functional, and in the default gateway section you see this is the default gateway information. But now instead of using this IPv6 address which we have assigned to this interface of the router, this PC is actually using the link local address of this interface. So this is G0/0/1. So if we go here and if we use this, for example, the same command, that is show IPv6, show IPv6 interface, and then we say brief. So in this you can see this is gigabit Ethernet 0/0/1. So this is the link local address of this interface, where this computer is connected. So we can just verify that in last we have this B102. So let's go here. You can see here in the default gateway, you can see this is B102. I hope you can see here. So the link local address is being used as a default gateway, and now to check the connectivity, if you want to check the connectivity, then we should be able to ping from this PC to this PC, or from this PC to this PC. So let's suppose that we are going to ping from this PC, because the IPv6 address assigned to this is just difficult to write it. So I'm going to ping from this PC to this PC. If it works, then we should be sure that this is working, and these both of the computers are connected through router. So the IPv6 address of this computer is FD00 and then colon 0, then colon A, then colon again A, then colon and 1. I have written sent because FD00, 0AA, and 1 is for this interface and 2 was for this computer. So this is 2, and then we press enter, and yes, great, we are getting the response that we sent 4 and received 4. It means we are able to communicate from this computer to this computer, and on this computer we just made a trick, or we just use a facility given by IPv6 address, that instead of assigning the IPv6 address ourselves, we just use this feature automatic. So by using SLAAC method, this computer assigned IPv6 address to itself automatically, and default gateway information was also retrieved, or it was received from the default from this router, and this is working. And yes, and if you have some confusion about that, how this link local address or how this unique local um, address is being created, so we have some video where we have discussed these all points. You are very welcome to see that video. And even so, this was some simple lab which we tried to implement by using uh, unique local unicast address. We didn't use this global unicast address. And yes, so the method will remain same, and you can do the same thing using global unicast address as well. So thank you very much for your time, and hope to see you again in some other video.